So I'm going to ask you a question. How many of you are aware of a fungus called mycorrhiza? No, not too many of you. Okay. Well, in nature, plants have to have an association with a fungus called mycorrhiza. This fungus actually helps to feed the plant. And it does a lot of other things as well. One of the other characteristics of this fungus is that it will prevent harmful nematodes from damaging that plant. A lot of farmers struggle with nematode problems damaging the roots of their crop. And they'll use pesticides, which Stephen's familiar with, for fumigating those soils to try to control the nematodes. But in nature figured out the solution to this problem a long time ago by creating a fungus that will actually attack and eat the eggs of nematodes. Mycorrhiza is something that is not well known in the world of agriculture and is not used a whole lot so far, but there's probably more research published in journals of science on it than anything else. Last time I checked, which was about 10 years ago, there was over 70,000 papers of research published in journals of science on mycorrhiza and all the benefits of it. And I'm sure that has magnified a lot over the past 10 years. So it's kind of crazy that we don't see it as a common product used in agriculture. We briefly talked about soil carbon sequestration a moment ago and what that actually is. But without mycorrhiza, it's very difficult for you to build topsoil. The building a topsoil is a soil carbon sequestration process. It doesn't get accomplished by putting compost down or putting other forms of organic matter down. That will certainly have a benefit, don't get me wrong, because compost provides nutrition that a plant can benefit from. But the way soils are built is by transferring that carbon from the atmosphere through the plant down into the soil, where it is then turned into a very strong molecular substance that we call a carbon matrix. This carbon matrix is the definition of what a healthy topsoil is. Sadly though, it has been disappearing from our soils of agriculture rapidly for quite a long time. Back about 2011, there was an article published in Scientific American titled Dirt Poor. And what that article basically exposed was that while testing, I think it was 43 different fresh fruits and vegetables between 1975 and 1998, I believe, there was a dramatic decline in the levels of vitamins and minerals in those foods in a very, very short period of time. I found a study that showed that if you were to eat oranges today compared to your grandparents eating oranges in the 1950s, you would have to eat 5 oranges today to match the nutrition of just one orange in the 1950s. That's pretty bad. And so we've seen, in some cases, a 30% or greater decline in nutrition in our food. And it's because our agriculture soils are in decline worldwide. Now, going back to 1968, I was 13 years old and I wanted to compete in the state 4-H soil judging contest. I was a 4-H'er. And my father, who owned the John Deere dealerships here in New Mexico and was a farmer, trained me on how to judge soils. So we were running around the Mesilla Valley where I grew up, Las Cruces, and digging holes in the ground and looking at that soil and manipulating it through our fingertips to estimate, the texture of the soil, the sand, the silt, the clay, etc. And while we were doing this, my dad stopped and he had a handful of dirt and he stopped and was looking at it and he says, Michael, everything we do in farming is wrong and it destroys this. We need to learn how to do a better job of taking care of our soils. This was coming from the John Deere guy, Romney Equipment Company, and a farmer. But he could see it already in 1968. So in 1974, I was a student at New Mexico State University taking a soil science class under Dr. Boyce Williams. Had to write a paper. So I wrote a paper titled The Soil Food Web. And I described the life in the soil and how it worked. You know, the bacteria, the protozoas, and the earthworms, and all these different creatures, and what their role was in developing soil and feeding a plant. My professor called me into his office, madder in hell. Had that paper in his hand, shaking it at me. And he goes, "Michael, this is a science class. This is not a science paper." Slams it on his desk, and he opens up his drawer, takes a stamp out, you know, those rubber stamps with the ink pad, and he dips it in the ink pad and stamps my paper. You know what grade I got? BS. Bullshit. And well, what I described in 1974 is now accepted, recognized by every soil scientist on this planet. You can go to the internet and look up Soil Food Web, and you'll learn exactly what I described in 1974, even though I was only 17 years old, and I was really just guessing. I was going with just intuition. What I described was absolutely 100% correct and is now accepted. So we know that you cannot grow a healthy plant if your soil is not healthy. You guys are farmers, right? You can't grow a healthy plant if your soil is not healthy. And we're facing a lot of problems with our soils. Down in the Mesilla Valley, Las Cruces, where they grow pecan trees, NMSU is telling farmers to take big old giant trenching machines out there into their fields and dig trenches across between the pecan trees, you know, going all the way through crosswise to try to get the soils uncompacted, because the soils are caving in, they're collapsing or dispersing, and water and oxygen is not able to penetrate. So the university is telling them, go out there with machines and dig it up. Well, you guys are farmers. That's pretty expensive to use machines, huh? The more equipment you have to take out in that field, the more fuel you have to purchase, and the more time you have to pay somebody to be operating that piece of equipment. That is taking away from your profit. And without profit, you cannot, well, I'm sorry, yeah, you can't have sustainability. We like to talk about sustainability in agriculture. You cannot have sustainability without profitability. You got to have profit. So if you're out there spending money trying to fix your soils by using machines and manpower, it's the wrong way. That carbon matrix, we know what that thing is. I'm the person who found it. I'm the one who went to the national laboratories years ago, both Los Alamos and Sandia, and I said, I want to know what the heck carbon is in our soils. Can you help me discover it? Is there a way to do what we call a molecular characterization study of that carbon? Nobody in the world knew what it was. We had names for it. Humic acid was one name, but humic acid has never been found. Nobody's ever found it. But we sell it. You can go to any fertilizer company in the country and they'll gladly sell you humic acid. However, we have no idea what it is. Would you buy something that the person selling it to you doesn't even know what it is? I wouldn't. So I went to Los Alamos labs and Sandia labs and I said, can you help me find it? And they said, of course, we can. And they embraced me into a program called a technology transfer program. And we collected soil samples from many different sites and compared it to the product that I was manufacturing at that point in time, and looked at it on a subatomic level to see exactly what it is. That's it right there. So that molecule, if I put 1,000 pounds of that molecule down on an acre of farmland, if I go out onto that farmland with a penetrometer before I ever do this, a penetrometer is a rod that has a gauge on it, and civil engineers use this, and they go out there and they can push that rod into the ground and measure how hard is that soil. Remember those pecan orchards down south that they're ripping up with machines because the ground's so hard. And well, we've gone out and done this with a penetrometer on orchards, where the PSI, the pounds per square inch, measured by that penetrometer, was at 300. It's pegging out. You can't push it into the ground more than a ½ inch. That ground is so hard. This is in orchards, and the water's not penetrating either. And if water can't penetrate, neither can oxygen. And everything that's good that has to happen in the soil is contingent upon water and oxygen, right? So if you can't get water in and you can't get oxygen in, you're in trouble. So that penetrometer can't get in 300 pounds of PSI. We put 1,000 pounds of that carbon down, and that's not just regular old carbon. This is bioidentical carbon matrix carbon. We are the only company in the world that can make it, because I'm the only one who knows what it is. Now, 6 months later, even less, 3 months later, I can go back out into that same orchard with that same penetrometer, and I can push it into the ground all the way the full length of the rod, and it will be lower than 75 psi. I can go anywhere in that field lower than 75 psi. Well, we know that microbes and roots cannot live in a soil that has a psi above 150. So if you're hitting 300, you're in big trouble. But I guarantee you, I can go all over New Mexico with that penetrometer and find that the farm soils are over 150. I see farmers out there, they're big subsoilers, ripping that ground, trying to get it loosened up again. Again, machines, that's expensive. We can do it quicker, and guess what? Permanent fix. I've studied the aging factor of these molecules. In the world of chemistry, molecules have what we call a chemical half-life. And so when we study the chemical half-life of this, you know how long that stuff will last in your soil? 3,000 years. You put it down once, and that's it. You don't need to do it again if you put enough of it down. So, yes, sir.
You mentioned just a little while back, I'm the only one who knows where you can find it.
Not find it. Make it.
Oh, okay.
Make it. Because we know what the molecule is.
Yeah.
And so we had to understand what the molecule is first.
Right.
And in order to understand what its characteristics are. Mm-hmm. So it's just like in the world of vitamins. You know, if you're gonna manufacture a vitamin versus extracted from a plant, and in the world of nutraceuticals, almost all vitamins that you buy at a vitamin store are manufactured. They're not extracted. Okay, they might say they're extracted. They're not. They're manufactured. They're replicated, and so that's how we have to do it. We have to replicate it, but we have to know what it is first. And I'm going to give you a real quick. We're probably running out of my time spot here. A real quick explanation as to one of the characteristics of that molecule. That molecule has a tremendous magnetic charge to it. This magnetic charge attracts water, so it's what we would call a humectant. Now, you have to understand, first of all, that water itself is attracted to anything with a negative charge. So, one way of looking at this is you can actually turn your faucet on in your kitchen sink to a slow dribble, and then taking a balloon or a plastic bottle like this, without water in it, it has to be empty, and you can rub that bottle on your shirt or on a stack of paper towels vigorously. You're building up a negative charge when you do that. Same thing if you take a balloon and you rub it on your shirt and you can stick it to the wall and it'll stay there, right? We all did that as kids. Then you hold it up close to that stream of water coming out of that faucet, and you'll see that water bend and go towards that bottle. Negative charge. The water has a positive charge, so the positive is attracted to the negative, so it's like playing with magnets. So in nature, one of the ways that water gets into the soil and stays there is if that carbon matrix has been accumulating over the past 10,000 years, has a strong negative charge, and is able to draw moisture out of the atmosphere, even if it's not raining. Draw moisture out of the atmosphere, hydrating those soils, so now you don't have to irrigate as much. Now, one example of that is pass this around. This is in Baja, Mexico. And this row of grapevines, this is a vineyard, was treated with 1,000 pounds of this carbon per mile of that line. This row was not treated at all. Okay, and this is the first summer that this happened. And as you can see, the one that's treated, the plants are much more luxuriant, a lot more biomass. But what's even more amazing is that the moisture sensors that are buried in this vineyard that tell the computers time to turn on the irrigation system, they're telling this row here go on every 4 days. This row every 21 days. That big of a difference. You can pass that around. So anyway, any questions on what I just said? Mycorrhiza is a fungus. You got to have it. It's easy to put on your plant. Hemp responds to it very well. All crops respond to it.
Carbon, is there a natural predator for it? Is there something?
Fertilizers.
Fertilizers?
Fertilizers destroy the carbon matrix.
So with fertilizers already in the ground over the last 20 years.
You're right. You're right. And we do a metagenomics test of your farm soil, which can be done nowadays. We discover that your farm soils are missing almost all of the critical beneficial mycorrhizal fungus and beneficial bacteria. Anyone who farms or gardens in New Mexico has experienced where certain nutrients simply can't be picked up by the plant. For example, iron. Your plant turns yellow in the summertime. We call that chlorosis. And we say, oh, we need iron. You run to the local nursery or fertilizer salesman and say, sell me some iron. And he says, oh, you need chelated iron. It works. It does temporarily fix the problem. But the real problem is that you're lacking a critical bacteria in that soil called Thiobacillus oxidans. It's a bacteria that oxidizes iron and helps a plant get iron. Okay, well, we can add that bacteria if you have that problem. But more importantly, mycorrhiza, the fungus mycorrhiza, will also harvest every single nutrient that plant needs. Will harvest it from your soil. Phosphorus, potassium, nitrogen, you name it. That mycorrhiza can get it into that plant. So you got to get mycorrhiza involved, and you got to get the carbon matrix involved in order to get on the journey to better soil health, and that's what we do. Thank you very much.
Each field would be different?
Nope.
When you do it? Or?
Not really. No, this is all about soil health, not really. You're not really programming to the field as much as you are just trying to prime the ecology back into that site. Right. And unless, of course, I've worked with some horrible situations in mine tailings, where the mine tailings of these lead mining companies in Missouri are so corrosive that if you picked up the stuff and held it in your hand, it would burn a hole through your hand. You don't have that problem. And well, how do we fix that? And so I can fix that and have fixed it. I just have to use a little bit more of this stuff.
Are you available? Are you
Yeah.
going to stick around?
I'll stick around.
Awesome.
So, okay, thanks.
Thank you so much, Michael.